So welcome, this is a video based upon Maclaurin series and extension to binomial theorem. So he's asking find the value of the Maclaurin series of the function f of x equals to e power 2x up to and including to the term x power 4. X power 4, what does it mean? I have to find it out till the fourth derivative. So first of all, f of x equals to e power 2x. First derivative, what does that becomes? 2 e power 2x. Second derivative becomes 4 e power 2x. Third derivative becomes 8 e power 2x, and the fourth derivative becomes 16 e power 2x. Now plug in 0 in the main function, it becomes 1. Plug in 0 in the first derivative, 2. Second derivative, 4. Third derivative, 8. And the fourth derivative is 16. Now use the Maclaurin series to get that one. So what does that becomes? F of x, which is f of x plus means f of 0 plus first derivative times x, then second derivative times x square upon 2 factorial, third derivative times x cube upon 3 factorial, fourth derivative times x power 4 upon 4 factorial, and so on. When I simplify that, I should be getting 1 plus 2x plus 2x square plus 4 upon 3 x cube plus 2 upon 3 x power 4, and so on. Now, the second option is nothing but what? Using the Maclaurin series of e power x. So he has given e power x Maclaurin series as 1 plus x square upon 2 factorial plus x cube upon 3 factorial, and so on. So in this one, wherever x is there, plug in 2x. So it becomes 1 plus 2x plus 2x whole square upon 2 factorial, 2x whole cube upon 3 factorial, 2x whole power 4 upon 4 factorial, and you can see that I'm going to get the same answer as 1 plus 2x square plus 4 upon 3 x cube plus 2 upon 3 x power 4. So irrespective which method is being followed, we are going to get the same answer. Question number 2. Now in question number 2, what is being asked? Find the Maclaurin series for f of x equals to 2 plus x whole cube by using the formula for Maclaurin series. So what am I going to do till x square? So what am I going? F of x, which is 2 plus x whole cube. Then first derivative, it becomes 3 times of 2 plus x whole square. Then second derivative, it becomes 6 of 2 plus x. And the third derivative, which becomes 6. Now plug in 0, it becomes 8. In the first derivative, it becomes 12. And in the second derivative, it becomes 12. And in the third derivative, it does not have any effect, 6. Now in that case, using the Maclaurin series f of x equals to f of 0, which is 8, first derivative times x, second derivative times x squared by 2 factorial, third derivative times x cubed by 3 factorial, and 0. So it becomes 8 plus 12x plus 6x square plus x cube. Using the binomial theorem. Now we have to use 2 plus x whole cube using the binomial theorem. So what does it becomes? 3c0, 2 cube, 3c1, 2 square times x plus 3c2 times 2 times x square, 3c3 times x cube. So it becomes the same. It becomes 8 plus 12x plus 6x square plus x cube. So either you do by binomial theorem or Maclaurin series, you are going to get the same answer. Question number 3. F of x has been given using the formula for Maclaurin series up to x square, means only up to the second derivative. So what is f of x? F of x is 2 plus x whole to the power of negative 2. F prime x, it becomes minus 2, 2 plus x whole to the power of negative 3. F double prime x, it becomes 6, 2 plus x whole to the power of negative 4. Substitute 0 in f of x, you'll be getting 1 upon 4. Substitute 0 in the first derivative, you get negative 1 upon 4. Substitute 0 in the second derivative, 3 upon 8. So using Maclaurin series, what does it becomes? F of x equals to f of 0, 1 upon 4, first derivative times x, then second derivative upon 2 factorial, second derivative is 3 upon 8 upon 2 factorial x square, and so on. So my answer is going to be 1 upon 4 minus 1 upon 4x plus 3 upon 16 x square, and so on. Now, by using the extended version of the binomial theorem, so it is 2 plus x whole to the power of negative 2. So take 2 common, 2 power negative 2, 1 plus x upon 2 whole to the power of negative 2. So it is 1 upon 4 times 1 plus nx plus n minus 1 by 2 factorial x square, and so on. So again, when I simplify, directly I'm writing it out, you will be getting the same answer. Next, write down the values for which the series is convergent. When will be the series will be convergent? When absolute value of x upon 2 should be less than 1. It implies x lies between negative 2 and positive 2. Question number 4. By using the formula for Maclaurin series up to x square means 2 second derivative. F of x equals to 2 plus x whole to the power of half. So f prime x will become 1 upon 2, 2 plus x whole to the power of negative half. Then f double prime x will become minus 1 upon 4, 2 plus x whole to the power of negative 3 upon 2. Then I am substituting 0 in the function, so it becomes square root 2. Then in the first derivative, it becomes 1 upon 2 root 2. And in the second derivative, it becomes negative 1 upon 8 root 2. Now, using the Maclaurin series, so what does that becomes? F of x equals to function plus 1 upon first derivative times x plus second derivative upon 2 factorial times x square. So when I simplify, you get square root 2 plus root 2 upon 4x minus root 2 upon 32 x square, and so on. See that always the denominator should be a rational number. Next, what is he asking? By using the extended version of the binomial theorem. So 2 plus x whole to the power of half. So it becomes 2 power half 1 plus x upon 2 whole to the power of half. So it becomes square root of 2 times 1 plus nx. N is 1 upon 2, x is x upon 2. Then n minus 1 upon 2 factorial, x upon 2 whole square, and so on. And it is asked up to only x square. So when I simplify, it becomes root 2, 1 plus x upon 4 plus x square upon 32, and so on. When I simplify, I should be getting the same answer, root 2 plus root 2 upon 4x plus or minus root 2 upon 32 x square, and over here also it is minus, and we get the same answer. Question number 5. Find the Maclaurin series of the function f of x equals to square root of x square plus 1 up to and including the term of x power 6 by using the extended version of the binomial theorem. So he is asking up using binomial theorem. So what is the thing is, f of x equals to x square plus 1 whole to the power of half. So it becomes 1 plus nx plus n minus 1 upon 2 factorial x square whole square will become x power 4 plus n minus 1 n minus 2 upon 3 factorial x power 6, and so on. Simplify that, 1 plus 1 upon 2 x square minus 1 upon 8 x power 4 plus 1 upon 16 x power 6 and so on. Given that f prime x equals to this much. So what is f prime x? F prime x equals to x upon square root of x square plus 1. Find the Maclaurin series of f of g of x equals to this one. So f prime x has been given as x upon square root of x square plus 1. We can clearly see that its derivative, f prime x derivative is nothing but what? 1 upon 2 root of x square plus 1 times 2x. 2 gets cancels, which is the same. F prime x is given over here. Now, what am I supposed to find it out? I am supposed to find it out the Maclaurin series for this one. So, which is nothing but what? G of x. So, as such, I know that f of x equals to, or else I know that square root of x square plus 1 equals to 1 plus 1 upon 2x square minus 1 upon 8x power 4 plus 1 upon 16 x power 6 and so on. So I'll be differentiating on both sides. So this becomes x upon square root of x square plus 1 equals to 1 derivative is 0. So 1 upon 2 times 2x minus 1 upon 8 times 4x cube plus 1 upon 16 times 6x to the power of 5 and so on. So what does that becomes now? X minus x cube by 2 plus 3 upon 8 x power 5 and so on. That's the Maclaurin series for x upon square root of x square plus 1. Question number 6. The Maclaurin series for e power x is given. Find the Maclaurin series for e power minus x. So just plug in my e power minus x over there. So x has minus x. So 1 plus minus x plus minus x whole square upon 2 factorial plus minus x whole cube upon 3 factorial and so on. So what I'll be getting it out over there? 1 minus x plus x square upon 2 minus x cube upon 6 and so on. Next, second part is part B, e power negative x square. So plug in negative x square over there. So 1 minus x square, negative x square whole square will become x power 4 upon 2 factorial. Negative x square whole cube will become negative x power 6 upon 3 factorial and so on. So you can write as 1 minus x square plus x power 4 upon 2 minus x power 6 upon 6 and so on. For part C, x e power x. So it is x times e power x is 1 plus x square by 2 factorial, x cube by 3 factorial and so on. So what does that becomes? X plus x square plus x cube by 2 factorial, which is 2, x power 4 upon 3 factorial, which is 6. Then part D, x square e power minus x. So x square e power minus x, just now we got it as 1 minus x plus x square by 2 factorial, which is 2 minus x cube by 3 factorial, which was 6 and so on. So my final answer is going to be x square minus x cube plus x power 4 upon 2 minus x power 5 upon 6. Next is e power x minus e power minus x. So e power x is 1 plus x square by 2 factorial plus x cube by 3 factorial and so on minus 1 minus x plus x square by 2 factorial minus x cube by 3 factorial and so on. So when I simplify that, I will be getting it out 2x because 1 and 1 gets cancels plus x cube by 3 plus x power 5 upon 60. This is going to be the answer. Check for the calculations. And for part F, what is part F? X plus 1 times e power 4x. X plus 1 times e power 4x. So plug in 4x over there. 1 plus 4x plus 4x whole square upon 2 factorial plus 4x whole cube upon 3 factorial and so on. So what does that becomes? X times 1 plus 4x plus 8x square up 8x square plus 32x cubed by 3 plus 1 times 1 plus 4x plus 8x square plus 32x cubed by 3 plus and so on. Then add them the like terms 1 plus 5x plus 12x square plus 56 upon 3 x cube plus and so on. Question number 7. Find the first three terms of the Maclaurin series of ln e power ln 1 plus e power x. So f of x. What is f of x? Ln of 1 plus e power x. So f prime x, first derivative will become e power x upon 1 plus e power x. Second derivative, use the quotient rule. So it becomes 1 plus e power x whole square, 1 plus e power x derivative is e power x minus e power x as it is, 1 plus e power x derivative is e power x. Now substitute 0 in the function, you get ln 2. Substitute 0 in the first derivative, you get it on 1 upon 2. Substitute 0 in the second derivative, you get 1 upon 4. So what will be f of x this time? Ln 2 plus first derivative times x plus second derivative times x square. Hence or otherwise, what is that? Limit x approaches 0 to ln of 1 plus e power x minus x minus ln 4 divided by x square. He is asking us to find it out that value. Now limit x approaches 0 to ln e power ln 1 plus e power x formula is this is what we have done it out. So what does that becomes now? Ln 2 plus 1 upon 2x plus 1 upon 4 x square. Then minus x minus ln 4 divided by x square. So what does that becomes now? This one was 1 upon 8. So what do I get there? Limit x approaches 0 to ln 2 plus x plus 1 upon 4x square minus x minus ln 4 upon x square. So we can clearly see that 2 ln 2 and ln 4 are same. X and x gets cancels. X square gets cancels. My final answer is going to be 1 upon 4. That's going to be the way. Question number 8. The function f of x equals to ln 1 upon 1 minus x. Write down the value of the constant term for the Maclaurin series of f of x. So the constant term is going to be when x equals to 0. So which is ln 1, which is going to be 0. Find the first three derivatives of f of x and hence show that the Maclaurin series up to x cube can be written like that. So my first derivative is going to be ln, you can write ln 1 minus ln 1 minus x. So it is nothing but what? Ln minus ln 1 minus x. Its derivative will be minus 1 upon 1 minus x times minus 1. So it is 1 upon 1 minus x is the first derivative. What will be the second derivative? Minus 1 minus x whole to the power of minus 2. What will be the third derivative? 2 1 minus x whole to the power of negative 3. Now find the substitute. In the first derivative 0, you get 1. In the second derivative, you substitute 0, you get 1. And in the third derivative, you substitute 0, you get it out 2. So what is f of x now? In the function, you substitute 0, that is 0 plus first derivative times x upon 1 factorial, first derivative times x square upon 2 factorial, then third derivative times x cube upon 3 factorial, and so on. So it becomes x plus x square upon 2 plus x cube upon 3 plus and so on. Use this series to find the approximate value of ln 2. So we want to find the value of ln 2. So what should be the value of x? So ln 1 upon 1 minus x should be equals to ln 2. So 1 upon 1 minus x should be equals to 2. So 1 minus x equals to 1 upon 2. So x equals to 1 upon 2. So plug in x equals to 1 upon 2 over here. So ln 2 is approximately equals to 1 upon 2 plus 1 upon 2 whole square by 2 plus 1 upon 2 whole cube by 3, which is approximately equals to 2 upon 7 or 0.667. Question number 9. F of x equals to ln of 1 plus sin x, so that second derivative. So first of all, first derivative becomes ln derivative is 1 plus sin x derivative is cosine x. Now second derivative, I am going to use the quotient rule. So 1 plus sin x whole square, then 1 plus sin x. Cos x derivative is nothing but what? Negative sin x. Next minus cos x, and sin x derivative is nothing but what? Cos x. So what does that becomes? Negative sin x, negative sin square x, and negative cosine square x divided by 1 plus sin x whole square. So take minus 1 minus common, so minus of sin square x plus cos square x. What is sin square x plus cos square x? Which is 1. So 1 plus sin x whole square. So it is negative sin x, negative 1 divided by 1 plus sin x whole square. So negative common, so 1 plus sin x upon 1 plus sin x whole square. Then 1 plus sin x, 1 plus sin x gets cancels, negative 1 upon 1 plus sin x. Next, find the third and the fourth derivative. So we got the second derivative. What was the second derivative? Just now we got the second derivative as negative 1 upon 1 plus sin x. So which is negative of 1 plus sin x whole to the power of negative 1. So what will be the third derivative now? So 1 plus negative 1 comes front, and 1 plus sin x whole to the power of negative 2 times sin x derivative is cosine x. This is the second derivative or third derivative, or else cosine x upon 1 plus sin x whole square. Now we have to find the fourth derivative. Fourth derivative will become, again use the quotient rule. 1 plus sin x whole square will become whole power 4. So it becomes 1 plus sin x whole square, cosine x derivative minus sin x minus 2 times of 1 plus sin x times cosine x, and the cosine x is there from the question itself only. So cosine x. So it becomes, or we can leave it out over there, that is the second derivative and the third derivative. Now what is else is being asked? Hence find the Maclaurin series up to x power 4. So I am going to find the values in the function. If at all I substitute 0, I get 0. If I substitute first derivative 0, I'm going to 1, get 1. Second derivative, you can check, I'm going to get negative 1. Third derivative, I'm going to get positive 1. And fourth derivative, try to check it out. You should be getting it out minus 2. Once I get that one, so ln 1 plus sin x will be, substitute 0, then 0 plus first derivative times x upon 1 factorial. Then second derivative times x square upon 2 factorial. Third derivative times x cube upon 3 factorial. Fourth derivative times x power 4 upon 4 factorial, and so on. So it becomes x minus x square upon 2 plus x cube upon 6 minus x power 4 upon 12, and so on. Question number 10. dy by dx minus y tan x equal to cos x. Find the Maclaurin series for y. up to and including the term x square, given that y equals to minus pi by 2 and x equals to 0. So what is dy upon dx? Dy upon dx is y tan x plus cosine x. Now, so that is the first derivative. So if at all I plug in 0 in that, I am going to get 1. Now I have to find the second derivative, which is d square y upon dx square. So which is y times tan x derivative is secant square x plus tan x will remain as it is. Y derivative is dy by dx. I use the product rule. And cosine x derivative is minus sin x. Now we know y value and x value, plug in that one. So my second derivative, when I plug in that one, I'll be getting minus pi upon 2. Plug in the values of y and x and the first derivative values, you should be getting it out. Second derivative is minus pi by 2. So therefore, the function will become now, if I plug in y value is nothing but what? Minus pi upon 2 plus first derivative is 1 times x upon 1 factorial. Second derivative is minus pi upon 2 times x square divided by 2 factorial. So it becomes negative pi upon 2 plus x minus pi x square upon 4. Show that the approximation of y when x equals to 0.1 is this much. So plug in x equals to 0.1. So you get it out minus pi by 2 plus 0.1 minus pi times 0.1 whole square by 4. So this becomes negative pi upon 2 plus 0.1 minus pi upon 400. So which is approximately equals to 0.1 minus 201 pi upon 400. That's going to be the answer. Now coming to question number 11. F of x is given. Use the binomial theorem, extended version of binomial theorem, to find the Maclaurin series till x cubed. So f of x equals to 5 plus 3x whole to the power of negative 1. So which is nothing but what? 5 power minus 1, 1 plus 3 upon 5x whole to the power of negative 1. So it becomes 1 upon 5, 1 plus nx, nx plus n minus 1 upon 2 factorial x square. Then n minus 1, n minus 2 upon 3 factorial x cube. So simplify that. You should be getting 1 upon 5, 1 minus 3 upon 5x plus 9 upon 25 x square minus 27 upon 125 x cube and so on. So what does that becomes? 1 upon 5 minus 3 upon 25x plus 9 upon 125 x square minus 27 upon 625 x cube and so on. Find the value of x when it is converges. When does that converges? When I have 3x upon 5, absolute value should be less than 1. Means it implies x absolute value should be less than 5 upon 3. Means x should lie between negative 5 upon 3 and positive 5 upon 3. Question number 12. F of x equals to square root of 3x plus 5. Then use the extended version of binomial theorem to find x cube and this one. So square root of 3x plus 5 this time. So f of x equals to 5 plus 3x whole to the power of half. So it becomes 5 to the power of half, 1 plus 3x upon 5 whole to the power of half. So it becomes square root of 5, 1 plus nx, 1 upon 2 times 3 upon 5x plus n minus 1 upon 2 factorial x square. Then n minus 1, n minus 2 upon 3 factorial x cube and so on. So it becomes square root 5, 1 plus 3 upon 10x, then plus minus 1 upon 4 upon 2 times 9 upon 25 x square plus 3 upon 8 upon 6 times 27 upon 125 x cube and so on. So simplify that. It becomes square root 5, 1 plus 3 upon 10x minus 9 upon 200 x square plus 27 upon 2000 x cube and so on. So what does that become? Square root 5 plus 3 square root 5 upon 10x minus 9 square root 5 upon 200 x square plus 27 square root 5 upon 2000 x cube and so on. When does the series converges? Again, absolute value of 3x plus 5 should be less than 1. It implies absolute value of x should be less than 5 upon 3. It implies x should lie between negative 5 upon 3 and positive 5 upon 3. Coming to question number 13. It is given that Maclaurin series of the function f of x equals to ln 1 plus sin x is given by this. So deduce the Maclaurin series for ln 1 minus sin x. So what we can see, that is 1 plus sin x, it became 1 minus sin x. So how can I write 1 minus sin x as ln of, let me write it out over here, ln of 1 plus sine of negative x. Means in that formula, plug in x as negative x. So it becomes negative x, negative 1 upon 2, negative x whole square, plus 1 upon 6, negative x whole cube, minus 1 upon 12, negative x whole power 4. So what does that becomes? Negative x, negative 1 upon 2x square, negative 1 upon 6 x cube, negative 1 upon 12 x power 4 and so on. Next is asking ln 1 plus x. Ln cos x. How do I get ln cos x? So for that, what's the work I should be doing? Ln 1 plus sin x plus ln 1 minus sin x. Why am I doing that one? It becomes multiplication. A plus b times a minus b is a square minus b square. 1 minus sin square x is cos square x. So it becomes 2 ln x. 2 ln cos x. So what I get there? 2 ln cos x equals to ln of 1 plus sin x plus ln of 1 minus sin x. So I am looking for ln cos x. Will be 1 upon 2 ln of 1 plus sin x plus ln of 1 minus sin x. So 1 upon 2 ln of 1 plus sin x. What's the value of 1 plus sin x is? X minus x square upon 2, x cube upon 6, x minus x square upon 2 plus x cube upon 6 minus x power 4 upon 12 plus ln 1 minus sin x. Ln 1 minus sin x, just now we found it as negative x, negative 1 upon 2x square, negative 1 upon 6x cube, negative 1 upon 12 x power 4 and so on. What can happen now? X and x gets cancels, x power 6 and x power 6 gets cancels. Now I have 1 upon 2, 2 times of negative, all the even powers are 2 times minus x power 4 upon 12 minus and so on. So 2 will get cancelled and minus final answer is negative x square upon 2, negative 1 upon 12 x power 4 minus and so on. That's going to be ln cos x. Next, ln secant x. He's asking us to find it out. Ln secant x. Ln secant x can be written as ln 1 upon cos x. Means it is ln cos x to the power of negative 1. Means it is negative ln cos x. So already we have found it out, ln cos x. So it is negative value of that. X square upon 2 plus x power 4 upon 12 and so on. Then by differentiating the Maclaurin series, y equal to ln cos x, deduce the Maclaurin series for tan x. So we have ln cos x. Ln cos x is minus 1 upon 2x square minus 1 upon 12x power 4 and so on. Differentiating both sides. Ln cos x derivative is 1 upon cos x. Cos x derivative is nothing but what? Negative sin x equals to minus 1 upon 2. X square derivative is 2x minus 1 upon 12. X power 4 derivative is 4x cube and so on. So negative tan x equals to negative x, negative 1 upon 3 x cube and so on. So multiply by negative on both sides. So tan x equals to x plus 1 upon 3x cube and so on. This is a formula for tan x. Next, hence calculate the limits of limit x approaches 0 ln secant x by x root x. Ln secant x by x root x and ln or limit x tends to 0 tan x square upon ln cos x. Part C 1 ln secant x upon x root x. What was secant x just now? We got it out. The secant x we got was x square upon 2 plus x power 4 upon 12 and so on divided by x root x. So divide each term with x root x upon x root x plus x power 4 upon 12 upon x root x plus and so on. X square upon x root x, I'm directly writing it out, it will become root x upon 2. X power 4 upon x root x will become x square root x upon 12 and so on. Now what is he asking? It is limit x approaches 0. So I'm applying limit x approaches 0 to that. Limit x approaching 0. Limit x approaching 0. Limit x approaching 0. Limit x approaching 0. So all the terms will become 0. So answer is going to be 0. For the next part, it is tan of x square upon ln cos x. Tan x square means we have tan x. In that tan x formula, plug in x square, you'll get x square plus x power 4 upon 3 plus and so on divided by ln cos x is minus x square upon 2 minus x power 4 upon 12 and so on. Now what am I going to do? Divide both numerator and denominator with x square. Divide this one with x square, divide with this one with x square. So you get 1 plus x square upon 3 and minus 1 upon 2 minus x square upon 12 and so on. Now again I am applying limit x approaching 0. Limit x approaches 0. Limit x approaches 0. So once I plug in 0, so I should get 1 upon minus 1 upon 2, which is negative 2. Next, by considering the difference of the two series, show that ln 3 equals to this much. So by considering the difference of those two series, what are those two series? Ln 1 plus sin x minus ln 1 minus sin x equals to ln 1 plus sin x upon 1 minus sin x. 1 plus sin x upon 1 minus sin x. So I am going to get it out this one. So what do I get? Ln 1 plus sin x upon 1 minus sin x. So ln 1 plus sin x is nothing but what? X minus x square upon 2 plus x cube upon 3, x cube upon 6 minus x power 4 upon 12 minus ln 1 minus sin x value was negative x square upon 2, negative x cube upon 6, negative x power 4 upon 12 and so on. So what does that becomes? 2x and x cube upon 3. Now this is ln 1 plus sin x upon ln 1 minus sin x. Plug in x equals to pi upon 6. So what does it becomes? Ln of 1 plus sin pi by 6, 30. Sin 30 is 1 upon 2 by 1 minus 1 upon 2 equals to 2 times of is approximately equal to. We cannot write equal to because we are not considering all the terms. So it is approximately equal to 2 times of pi upon 6 plus pi upon 6 whole cube upon 3. So this becomes ln 3 upon 2 upon 1 upon 2 equals is approximately equal to When I simplify this one, pi by 3 common, 1 plus pi square upon 216. So this is ln 3. Ln 3 is approximately equals to pi upon 3 times 1 plus pi square upon 216. And finally, coming to question number 14. Given that y equal to ln cos x, show that the first two non-zero terms of the Maclaurin series y is this much. So f of x equals to ln cos x. I'm going to find first derivative. Ln cos x derivative 1 upon cos x. Cos x derivative minus sin x. So it becomes minus tan x. Second derivative. Tan x derivative is nothing but what? Secant square x. Third derivative minus 2 secant x. Again secant x derivative is secant x tan x. Then fourth derivative. Basically it is minus 2 secant square x tan x. So I use a chain rule or product rule. First minus 2 secant square x as it is. Tan x derivative is secant square x. Next time tan x as it is. Minus 2 secant square x is minus 4 secant x. Secant x derivative is secant x tan x. Now what am I doing it out? I am finding it out the zeros of that one. So in the function, if at all I substitute 0, ln cos 0 is 1. So ln 1 equals to 0. Plug in 0 in the first derivative, it becomes 0. Plug in 0 in the second derivative, it becomes minus 1. Plug in 0 in the third derivative, it becomes 0. Plug in 0 in the fourth derivative, it becomes minus 2. So what will be my series now? Ln cos x is approximately equals to, first term becomes 0. Now second term also became 0. The third term is third derivative, or if you want to write it out, it will become f of 0 plus x times f prime 0 plus x square upon 2 factorial times second derivative plus x cube upon 3 factorial times third derivative and x power 4 upon 4 factorial times fourth derivative. So it's going to be negative x square upon 2 factorial minus 2x power 4 upon 4 factorial. So which is negative x square upon 2 negative x power 4 upon 12. Next, use this series to find an approximation value in terms of pi for ln 2. So I take x equals to pi upon 3. So ln cos of pi upon 3 equals to pi is approximately equals to pi upon 3 whole square upon 2 factorial minus 2 times pi upon 3 whole power 4 upon 4 factorial, which is ln 1 upon 2 is approximately equals to this one minus pi square upon 9 upon 2 minus 2 times pi power 4 upon 81 upon 4 factorial is 24. So this is minus ln 2 is approximately equals to minus pi square upon 18 plus minus pi power 4 upon 972. Minus minus cancels. Ln 2 is approximately equals to pi square upon 9 common. So 1 upon 2 plus pi square upon 108. That's going to be the approximate value of ln 2. So that completes the video. See you in the next video. Bye.